It's chapter 4, section 4. So I'm going to do 4, understanding slope. And if you think of slope, where else do you hear the word slope used? Hills, like skiing. And you can kind of think like if you have a hill that is steep, it's going to make you go fast, so that would have a high slope. If you have a hill that's real gradual, you're not going to speed up very quickly going down it. That would have a low slope. That's kind of where we're going. But that's kind of what I think of, is I think of skiing. So I'm just going to start by slope. And in absence of giving you like the official definition with x1s and y1s and stuff like that, just want to say that slope really is just looking at the steepness of a line. So slope describes the steepness of a line. So if you're out west skiing, or even someplace here, you get those hills that are like the double black diamonds that maybe you can go down, but I would probably die. That's going to be something that has like a really steep slope. It has a high slope. I kind of thought I would just take the slopes and put them in kind of like 4 different categories. And so if we were to take and just kind of draw a half-hearted graph, this is only which quadrant of the graph is supposed to be? Quadrant number 1, quadrant number 1. Because if I were to put the whole graph in there, it'd look something like that. So, all right. So much for review. Quadrant 1. If we did a line something like this, they always work left to right when they're looking at slope. Do you agree this line here goes up as you go left to right?
Yeah.
So if something goes up, is the slope going to be a positive number or a negative number? Positive number. Is it going to be a real big slope for that? Now, if you're sledding down that, other than maybe you're hitting this vertical wall here on the y-axis, you're not going to speed up real fast. But this is going to have a small positive slope. And if I wanted to draw one that's going to have a large positive slope, how's that going to be different?
It's going to go like straight up.
Yeah. Not straight up, but and we'll come into why, but at least a whole lot steeper, And I guess I could have even went quite a bit steeper than that if I wanted to. But, so something like that. But you can't have a vertical line. That does something weird with slope. But so this here would be a large, still positive or negative?
Positive.
Yep. So large positive slope for that one. And then we could, if we wanted to have a negative slope, then a wise person would just say the line has to be going down. So maybe let's do like a gradual down. So then this would have large slope, small slope. So small, seems like you get it. Small negative slope. And then last but not least, if we wanted to do a large negative slope, you just have to have it steeply going down. So large negative slope. Bless you. How you doing? Feeling okay on that one? So I'll give you a second to copy that. All right. For now, the equation we're going to have for slope isn't going to be something really for points, but we're going to say this. I'm going to put it in red for dramatic emphasis. This would be worth writing big or putting a box around or something like that. But slope is going to equal rise over run. Which one of those sounds more like something that's going to be vertical? Yep, rise is going to be vertical. When you rise in the morning, you get up. Running, you can think running is more horizontal. It's at least a whole lot easier to run if you're on flat ground. If you get a steep uphill, it just hurts. If you have a downhill, your knees start to hurt after a while. So really what we're looking at is we're looking at the change in y value, the rise, how much does it go up and down, divided by the side to side, the run. Some teachers, they'll go and they'll write the rise, with a y, kind of like R-Y-S-E. To try to emphasize that that's going to be in the y direction, the up and down. So kind of do it however you want to with that. All right, so if we were to have a graph, so let me try to make a graph here. And if I were to put a line on there, something like this maybe. If you could find some points on the line, so maybe I'll pick like a dot here and a dot there. If you wanted to figure out the slope of that blue line, well, if I drew a perfectly straight line, would the slope be the same everywhere, or would it be different? Same, because if it's going up at the same rate, it'd have the same slope. So I could pick a couple points on that line, and if we wanted to figure out what the slope was, you could take and turn it into a right triangle, and you have your rise being that there, how much does it go up? Then you have your run being how far does it go horizontally. So that would be how you could get the slope from a line. Good? If we're looking at that, as far as that blue line is going to be positive slope or negative slope. Blue line should be positive. Because if you're looking at the run, if you look at it as though this thing is going to the right, so maybe I have like my first point, my second point. I don't know if I'd mess up your drawing with this. But if I say my first point's the one on the left, well, in going from that first point to the second point, do you agree I'm going towards the right in the x direction? So that would give me a positive run. I probably should have started with a rise. But then I have to go up to get to point number 2, which would be positive on the y-axis. So essentially you have a positive for the rise over a positive for the run, so you get the positive slope. You could build the argument if you wanted to, well, what if you go in the other direction? What if you went from point 2 to point 1? Well, if you're going from point 2 to point 1, you agree you'd be going down for rise, which then would give you a negative. And then you're going to the left for run, which would give you a negative. A negative divided by a negative is positive. So it doesn't really matter what order you do the points in. If it's going up and to the right, it's going to be a positive slope. All right. Then if we were to, why not? This next one, I don't know if I'd copy this or not. I'm just going to try to do the same sort of thing, but with a negative slope. So if I have one like this here, pick a couple points on there, make my right triangle. Now when I do my slope is rise over run. If I'm going from one point to the other point, my rise is downwards. So you agree that's going to be a negative in the y direction? So as I go down from 1 to get to 2, I have a negative. But then I go across to the right, from kind of the corner of that triangle over to the 2, which then gives me a positive. So a negative divided by a positive is going to give a negative slope, which down and to the left then will always be negative. Any questions on that? The last thing then is going to be an example. I'm going to say draw a line through the origin, although you could pick any point, but draw a line through 0, 0. It's supposed to be 0, 0. So draw a line through 0, 0 with a slope of maybe 2/3. So you'll see some questions like that in the homework. They'll give you a starting point, then they'll give you a slope. And it's going to be a whole lot easier. In hindsight, maybe I'll just do this and go right over the top of where I wrote there. So draw a line through 0, 0 with a slope of 2/3. So if I'm doing that, we know that 0, 0 is going to be on the graph, right? And when we have this 2/3, we have 2 is going to be the rise, and 3 is going to be the run. So if I'm starting at my origin, if I'm starting at that point there, to get another point, I have to rise, I have to go up 2, so up 2, and then run a positive 3, so 3 to the right. So that would be another spot on my graph, the big orange dot, big red dot. Good? And you could draw a line through there. You'll be a whole lot more accurate if you do that a couple more times and say, okay, I could go up 2 more, 3 more to the right, my big dot there, up 2, over 3, and so on. And if you do it right, you should get a bunch of points that are all in a nice row. If you wanted to go to the left, get some points that were on the left, you'd have to go down 2 and then 3 to the left. Essentially what you're doing is you're saying, all right, the slope is 2/3. Well, that's the same as -2 over -3. Those negatives would cancel. So -2 for a rise means down 2. -3 for a run means 3 to the left. So you could get a bunch of points that way.
Can't you do 3 to the left and 2 down?
Yeah, that would totally work too. Yep, if you did 3 to the left, so 1, 2, 3 left, 2 down. Yep, good. And once you have a whole bunch of points, we'll see how well I do connecting them. Something like that. Two tricks. One, you'll see some questions like this, but maybe they'll tell you it starts at -4, 1 or something. Well, then where we started at the origin, you would just have to say, okay, -4 gets me 4 to the left and up 1. So then you'd start there at this green dot and then use your slope to get the points. The other trick, and then I'll jump to you, if that's okay. The other trick is this. If they tell you that the slope, get a new page. If they tell you the slope is 4, sorry, you're not used to the M. They tell you slope is 4. Before the slope was like 2/3, so we had a rise over run. How do we take the 4 and change it into a fraction so we could say rise over run? 4 over 1, yep. So if you just get a single number, you could put that over 1, then this would be a steeper line. It goes up 4 every time it goes 1 to the right.